In this video, we will discuss about the methods of facility layout. So we have already seen what is facility layout in the last lecture. Facility layout basically deals with how you are going to arrange the departments around a facility. For example, for a manufacturing uh, firm, that means arranging the various milling machines, various drilling machines, various grinding machines. So it involves where should be the location of milling machine, drilling machine, grinding machine, etc. So here we will discuss about the methods of facility layout. That means how to find the locations for the various departments. So there are mainly three methods that are used. First one is minimizing total transportation cost or distance. So all these methods are mainly used for a process layout. We have seen that what exactly is a process layout. So the first method is to minimize the total transportation cost or distance. So that means, see, while during the operation sequence, the material needs to be moved from one department to another and then to another department like that. So our overall aim is to minimize the distance traveled by the raw material. That is basically weight into distance. Okay. So that means to reduce the total transportation cost and the material handling cost. And second method is the closeness rating. So that is called systematic layout planning. So in this method, the facilities are arranged on the basis of their proximity or the closeness ratings. That means some departments need to be very close to each other. It is essential for them to be close to each other, and some departments it is not important for them to be close together, and some departments should not be close together. Like that, there are several closeness ratings. On basis of these closeness ratings, we will arrange the facilities. So that is this method, closeness ratings method. Then we have dedicated computer softwares which are used to assign locations for the various departments in a facility layout. So now we are going to discuss about travel chart, that is based upon the first method, that is to minimize the total transportation cost. So this is mainly used in a process layout. So and the objective is to reduce the total amount of weight transported across the various stations. That means we have already seen there are several departments. That means the material needs to be transported from here to here and then to here like that. So what we are trying to do is to minimize the total amount of weight transferred. From here to here, there may be a transfer of 50 kilo and the distance may be some 200 meters. So that is 50 into 200. Okay, like that we will calculate the total weight into distance and we will try to minimize it. Right, that means that is how we will arrange the various stations. So let us understand it with an example here. Okay, so we are given 5 different sequence of operations. Like, see, you can see for product 1, the operation sequence is A, B, D, C, E. Okay, A means, see, it can corresponds to milling, B corresponds to drilling, and D corresponds to lathe, like that. So there can be several sequence of operations. So you can see that for this operation sequence, that means from A to B to B to D, like that, the weight transferred is quantity per day is 50 kilogram and the weight is 0.2 kilogram. Okay, and for product type 2, the operation sequence is BDE. That means the weight transported is quantity is 10 and weight is 0.1. Like that, there are 3 types of products, 5 types of products made, and the operation sequence is given, and also the quantity and the weight transferred is also given. Right, and then the workstation that is given by A, B, and C. These are the shops. Okay, so the distance between the shops is also given here. From you can get this from the table. That is from A to B it is 10, A to C it is 5, A to D it is 12, like that. Some from D to D, that will be 0, that is obvious. From D to C it is 8, like that. So the distance is also given. So our aim is to place, for example, A. Where should A be placed? Should it be placed in A, and B should be placed in B, C should be placed in C, D should be placed in D? So this is one way of a layout, or it can be a different like this. B can be placed in A can be placed in B, like that. So there are several layout available. So we will find out the layout, the best layout. The best layout is the layout in which the total transportation cost is minimum. So that is the aim of this design method. So let us look at the first cycle. Okay, in this cycle what we are doing is, so we have placed the operation small a in the shop capital A, and B to B, C to C, D to D, and E to E. Okay, so we have placed the operations in the respective shops, right? So the job sequence is A, B, D, C. It will not change. So these are given in the question. And since these jobs are placed in these shops, the job movement will be capital A to B to D to C to E, like that. It goes on like this. So if you are placing A in B, then this will be different. Okay. So we have kept these in various shops. Then this is also given in question, that is we have given the sequence of operation A, B, D, C, E. Since we have placed these operations in the respective, in these shops, that is capital A, B, C, D, E, you can see that the total quantity transported is 50 into 0.2, that is 10. And here in 2, for product type 2 it is 1, for product 3 it is 10, like that. Okay, this is like this. Now, okay, next step. So all these were given in question, and this we have made a layout like this. Then we will check the total transportation, total weight into distance transported. Okay, now next step is to find the quantity into weight, that is the total amount that is transported. So that means, what is the amount transferred from the shop A to B? Okay, how to find it? A to B, you can see that the job movement here. So A to B, okay, A to B, and here A to B, and you can see here there is again A to B. Okay, so the quantity transported is 10, and then you have the 15. So 10 plus 15 is 35. Okay, then we will find out what A to C, what is the quantity transported from A to C. So we will look at the sequence of operation. You can see that there is no sequence of operation, there is no A to C here. Okay, nowhere you can find A to C. There is C to A, but there is no A to C. Okay, so that is 0. And then we will look at B to D. Okay, B to D, you can see that there is here B to D, here there is B to D, and then here you have B to D. Okay, then here you have B to D. That means you need to sum 10 plus 10 plus 9 plus 15. 10 plus 1 plus 9 plus 15. So that is again 35. So in this manner, let us look one more also. So B to E. So B to E, if you look at it, is okay, there is, okay, you can find one B to E here, and there is the only one, so that is 10. Okay, similarly you can find the quantity into 8 weight that is transferred from one shop to another, and you will get a table like this, 35, 34, 34, like that. So in next step, so we have found quantity into weight, and this is given, distance is given in the question. So if you multiply these corresponding values in the table, that is 35 and 10 and 34 and 8, like that, if you sum it up, that means you will get quantity into weight into distance. Okay, if you calculate all these, you will get the, so this were given, these were given. So if you multiply it, you will get 35 into 10, that is 350, and then this 35 into 6 gives 210, like that, right? And if you sum these, sum all of the find the sum of all of this, you will get it as 1268. That is the total quantity into weight into distance that is transported, that is 1268. Okay, so this is the first cycle. So in this layout, we have placed the drilling operation in shop A, turning operation in shop B, milling operation in shop C, like that. So we will try with another layout. So in the second cycle, I am changing the layout a little bit. That means drilling is placed in A, turning is placed in B, but thread cutting, that is small d, is placed in C, and milling, small c, is placed in D. That is the difference. That is, I am trying with this layout. Okay, so the job sequence will remain unchanged, but the job movement will be changed. So that means instead of C to A, you have D to A to B to E to C, like that. Okay, so again, so we will find like this, what is the total quantity into weight 10. You can see that for the operation A, B, C, D, E, and B, C, E, etc. C, you can see that there is, instead of D, you have C here, and instead of C, you have D here. Okay, you can see, find the D here. Okay, so we will calculate the quantity into weight. And this is already given, distance between the various shops. Okay, so in this step, again, we will calculate the quantity into weight that is moved from A to B, A to D, etc. From A to B, you can see that just like the previous example, it is A to B, A to B. So it will come out to be 35. You sum it up, it is 35. And from C to D, okay, C to D, sorry, from C to D. Okay, from C to D, you can see that there is C to D here, and then you have C to D here, and then you have C to D here. So if you sum this up, 10 plus 9 plus 15, it is 34. So similarly, you can find the quantity into weight moved from one shop to another, and the distance is given here. So next, so we have found the quantity into weight and also the distance. Now we will calculate quantity into weight into distance. That means we will multiply the corresponding values in the table. So you will get 350, 210, 100, etc. And if you sum all these up, you will get 1470. That means this second layout is inefficient compared to the first one, because in the earlier case we had the total transportation was only 1268. Here it is increased to 1470. So this layout is not desirable. So we will stick to the first layout. We will try with now different types of layout by changing the shop floor, by changing the operations in the different shop floors, and we will find the, in this way we can find out the best layout. So if you are doing this in an Excel, then you can get immediate results without any hassle.